Hello viewers, so you're welcome to Webinar Hub. So in this video, we'll be looking at electrolysis for JAMB chemistry. Okay, so JAMB chemistry, electrolysis. So it's a very important topic because JAMB always set questions on this particular topic. But if you know the basics, trust me, there's no way you can miss any question that comes out under this topic. So we're going to start with definition, look at the Faraday's laws of electrolysis, and other things like that. So you're welcome to the class. So the topic is electrolysis. So we'll start with the definition. I'll give you a formula, a very important formula that will help you in your JAMB chemistry. With that formula, trust me, there's no way you can miss any JAMB question, especially the calculation that will come out on this topic. But for today, we will not focus on the calculation part. But if time permits, we might keep calculation. But I'll just give you guys definitions and every other thing you need to know about electrolysis. So you're welcome to this class. So ionic theory now, this is JAMB chemistry. So let's start with the first one. So looking at the definition now. So please follow up and make sure you ask questions in the chat section. Now, let's start with electrolysis. Now, what's electrolysis? So electrolysis comes from two words. You have electro and lysis. So electro means current now, Abby. Why lysis means breakdown. Okay, this one means breakdown. So the act of using electric currents to break down a compound into its component form is what is called electrolysis. Okay, so when the compound is broken down with the aid of electrolysis into its component parts, then you say electrolysis has happened. Okay, so there's some important things you need to understand when you're talking about electrolysis. You talk about the cathode, electrolyte, and things like that. So I'm going to start with the first one, which is electrolyte. So electrolytes, what is electrolytes? Electrolytes can be defined as, you define electrolyte as a compound. It's a compound which, when placed in molten form or in solution form, will conduct electricity. Any compound which, when placed in molten form means it is melted, or when it is in solution form, and that compound is able to conduct electricity, then that compound will be called an electrolyte. So this electrolyte will be placed in like a bath like this, like a bathtub. Then you have two rods like this coming in. These two rods will be connected to thank you, Ifelua. Thank you, Ifelua. I'm okay. How are you? So these two rods will be connected to a current source, like direct current source. Okay. Then after that, you are going to have an electrolyte inside here like this. Electrolyte will be here, will be placed here. That electrolyte will be, this is the electrolyte here. And you plug everything to a DC source, direct current, not ACO. We use direct current when we're talking about electrolysis. Now, if this thing is connected to a circuit, maybe a battery and everything, this whole thing will break down the compound. So the compound, assuming the compound is HCl, for example, maybe it is HCl, that compound will dissociate, and so you're going to get H plus and Cl minus. Okay, so as time goes on, I'm going to give you the formula. Trust me, there's no way you will miss any JAMB question if you follow me and watch this video carefully. Okay, so watch this video carefully. Let's start with, I've done electrolytes now. I hope you understand. Electrolyte is a compound which will conduct electricity when it is placed in molten form or solution form. JAMB asked the question last time, like, when does an electrolyte conduct electricity? So it happens in two ways: when the compound is in molten form or solution form. Okay, I hope you understand that one now. Let's move to the next one. The next one I'm going to talk about is cathode and anode. Cathode and anode. Now, what is cathode? So look at our setup here. This is our electrolytic setup. So you have a rod called the electrode like this going into the solution like this. So you have a rod going to the solution like this. Then this one will be connected to a direct current source like this. This is a battery here. This is the positive terminal. The longer one is the positive terminal. This is the negative terminal. Then this one will be connected back like this to this one here. So this one is connected to the negative terminal. So it's connected to the positive terminal. This negative rod connected to the negative terminal of the battery is called the cathode. While this one that's connected to the positive part of the battery is called the anode. So the cathode and the anode are two rods that are dipped into the electrolyte. It is the means through which the current gets into the electrolyte. This is the electrolyte here. This one is the electrolyte. Okay, which conducts electricity when it is in molten form or solution form. And the next thing to note is that this cathode is a positive terminal. It is through the cathode that the current will enter the electrolyte. The current will pass like this. See, like this. Can you see my hand? Like this. Then to enter here, to pass through the electrolytes, then it will go back through the cathode like that. So the current flows from plus to minus, but the electrons flow in the opposite direction. The electrons are flowing like this. This electron flow. You know, current and electron flow, they are different. The conventional direction of current that is taken as a standard is current flows from positive to negative, but the electrons are flowing in the opposite direction. The electrons are flowing like this. Okay, they're flowing in this direction. So anode is positive. Positive terminal is anode. Noted. Okay, we have noted that one. Then the cathode is the negative terminal. And another thing you need to take note of is what is called a conductor and a non-conductor, or you can see an insulator. So when you talk about conductors conduct electricity, okay, freely, because they have free mobile electrons. They have free electrons in them, so they can conduct electricity or heat easily. While non-conductors, also called insulators, they do not conduct electricity. Okay, because they do not have. Okay, Ifeoluwa, no problem. Just give me the topic. Type the topic you want me to teach. Ifeoluwa, just type the topic. Welcome, guys. All of you are welcome. Just let me know the topic you want me to teach. Once you tell me the topic, I'll teach it. It's very easy. So, non-conductors, they do not conduct electricity. Okay, they do not, because they do not have no free electrons to carry the current. So please understand this thing very well. JAMB will definitely test you. JAMB 2026 is going to be very interesting, and I want to cover the syllabus with you guys. So note this thing very well. Conductors conduct electricity because they have free mobile electrons. Non-conductors do not conduct electricity because they do not have free mobile electrons. And you know that for current to flow, there must be a closed path. If current wants to flow, there must be a closed path. If there is a break, maybe this is a bulb here, and you now plug it to a battery. If this wire should cut into two, there's a cut, the bulb cannot on. There must be a closed path, a closed full circle for current to flow. You understand? So that means as this thing is flowing like this, as this current is coming like this, coming through the anode, entering to the solution. Once the current gets to the solution, you can see that this place is like as if it's liquid. It is the ions that will now carry it, the ions here, they will carry that current and move to this part. So this stuff, this electrolyte here, is serving as a conduction part. It will move the current from inside this anode, move it down. It will not pass through this one. Then it will not go up like this and go like that and continue like that. Okay, so this thing is very, very important. I hope you understand that part. The next thing to note is what is called reduction and oxidation. I'm going to explain to you. It's very, very simple. It's serious. It's very simple. It's very simple. So most students normally confuse it, but there's a trick I'm going to give you. A simple trick. If I give you this trick, once you use it, trust me, you can never miss oxidation and reduction. So let me do an example. This is reduction here. So let's talk about reduction, and I'll tell you where reduction occurs. So reduction means gain of electrons. Okay, gain of electrons. When a substance gains electrons, that substance will be reduced. You understand? So, and this reduction always takes place. It takes place at the cathode. Reduction takes place at the cathode. Please note that. Note that reduction takes place at the cathode. So, from your law of like charges attract, unlike charges do not attract. This is the anode here. This is the cathode. The anode, the cathode is negative. Our anode is positive. So that means negative ions, since the anode is positive, that means negative ions should be attracted to it now, Abi. Since plus and minus attract, unlike charges attract, like charges repel. Since the anode is plus, positive charges cannot come there because they are going to repel. So this cathode that is negative, it is the positive, that's the cations, the positive charges that will go to the cathode because the cathode is negative. So because the cathode is negative, positive charges will go there, and once positive charges gets there, they will not accept electrons. Once they accept electrons, they will not become reduced. So an example is like this. You have sodium, Na. Okay, you can see sodium is Na, but in solution here, it's been aqueous form. So you have to write plus at the top here. This is sodium in aqueous form because it has dissolved and you cannot see it. It is dissolved in solution. So I'm going to write Na plus. Then you now write plus. You now put E minus. This is telling you that sodium is going to the cathode. And once sodium gets there, sodium will accept one electron. You can see plus E minus. Once this happens, sodium will now change back to the normal form of sodium, which is the atomic sodium, not charged. This one is charged. So positive, this is plus 1, this is minus 1. 1 minus 1 will give you 0. That means our answer should be Na. We are going to write S at the bottom because it is solid. Everything here is now 0. The oxidation number here is 0. So you have plus 1, 1 plus minus 1. That is 1 minus 1. This is 1 electron. It's going to give you Na plus. Sorry, Na. This Na is the atomic form of sodium. Normal sodium. That means sodium has been reduced. That's the meaning. Reduction means that this reduction means that the oxidation number will drop. Oxidation number will reduce. Once the oxidation number reduces, that is reduction. Don't confuse yourself. This is N. This is plus 1 here now. This is plus 1 now. But here, what do you have here? 0. It does not have any charge. That means it's 0. That means plus 1. If plus 1 change to 0, what's the meaning? That means it reduced. And if something is reduced, that means it has undergone reduction. And this reduction always takes place at the cathode. They can ask you, reduction takes place at where? Reduction always takes place at the cathode. Reduction takes place at the cathode. Okay, so this is the cathodic reduction. You can call this formula, some textbooks will call it the cathodic equation. Now let's try for calcium. Calcium is group 2 element. Don't forget, calcium is group 2. So let's try calcium. That will be Ca. You put 2 plus here because the calcium is in ionic form. It's dissolved. You cannot see it. It is ionic. Now you want to see it now. That means you want it to appear. That means it has to be reduced. Give it 2 electrons. 2E minus. because it is 2 plus here. Ask yourself, how can you make plus 2? How can you make plus 2 to become 0? That means you have to put minus 2 on it. You have to add minus 2 to it for it to be 0. So Ca2 plus, now I want it to become Ca, ordinary Ca. That will be Ca2 plus 2A minus. That will now give you Ca. Put S here, that is solid. The calcium has been reduced from plus 2. It changed to 0. That means it has been reduced. Okay, so this is just reduction. I hope you understand. Is there any question on reduction? I hope you guys understand reduction. Reduction means gain of electrons. Now, let me explain oxidation for you now. Oxidation is very simple. It's very simple. Now, look at oxidation here. Now, oxidation is loss of electrons. Don't forget, reduction is gain of electrons. Reduction is gain of electrons. So that means oxidation is loss of electrons. Now, look at what how it is. This oxidation, it takes place at the where? At the anode. Oxidation takes place at the anode. Reduction takes place at the cathode. To remember it easily, just use this formula, cryo. CrO. Cathode reduction, anode oxidation. That's the short formula. Cathode reduction, anode oxidation. That means at the cathode, you have reduction. At the anode, you have oxidation. So oxidation means loss of electrons. When a substance loses electron, it will become oxidized. That's the meaning. So look at what is going on here. Let's try sodium now, Abi. So sodium is group 1 now. So Na, it will be in solid form. It's not charged, ordinary sodium. Now I want this sodium to turn to Na plus. That means I want to oxidize it. Okay, I want to oxidize it. So this space is not charged. The oxygen number here is 0. So yeah, it will not come here. This will be Na plus. Just write plus E minus here. Plus E minus. So you can see the difference between that former one and this one. So Na plus E minus, it means that sodium has lost 1 electron. When sodium loses 1 electron, it becomes an ion. You understand? So this is not ionic form. This is, this is not aqueous now. So that means sodium, it has disappeared though. Yeah, you can see it here. This is sodium that you can see, solid. But now, you cannot see it again. The reason why I cannot see it again, because it has dissolved. But if you look at reduction now, let's check the one I did. Just sorry for the, let me just the difference between the two, so you understand it better. Look at reduction. Reduction, it has dissolved, but you want it to appear. It's dissolved now. You want it to appear, so you give it 1 electron. It will now appear. You will now see the sodium. That is why it is NaS, solid. You can see it. You understand? But in oxidation, you can see it and you want it to disappear, to become aqueous. So you let it lose 1 electron. Once sodium loses 1 electron, it now becomes Na plus. So it that disappear. You cannot see it again. This reaction will take place at the anode. So you call it anodic reaction. Or you can say reaction at the cathode. You can say this is anodic equation or anodic reaction. Let's try for another element. Let's try for aluminium. Aluminium is group 3. Sorry. You can call aluminium group because the charge is 3. You can call it group 3. So Al, solid. Now I now want this Al to become Al3 plus. That means I must add 3 electrons at the right hand, 3E minus. So you can see this is aluminium now, solid form, but it has not disappeared to this one. This process is oxidation. This is oxidation. So oxidation takes place at the anode. Reduction takes place at the cathode. Once you understand this one, trust me, you cannot make any mistake concerning your electrolysis. How to write the equation. Okay, so which is, let's try electrolysis now. Let's look at the electrolysis of some common compounds. But before you can know that electrolysis, you have to talk about, let's talk about cations and anions. So a cation is a positive ion now, Abi. A cation is a positive ion. Once an ion, sorry, I'm looking for space. Once an ion loses electrons, it becomes positively charged. Okay, positively charged. And once maybe an element gains electron, preferably a non-metal, it becomes charged too. So for cations, also called cations, you have they are mainly metals. While the anions, they are mainly non-metals. So the first one, Na plus, when you see Na plus, Ca plus, Ca2 plus rather, Al3 plus, Pb2 plus, after it has plus, all of them are what? They are cations. These are all cations. But when it has minus, Cl minus, OH minus, SO4 2 minus, this is the hydroxide ion, sulfate ion, chloride ion, all these one are ion, anion, they are all anions. So they are negative. So anions are negative, cations are positive. Okay, if you don't worry, these topics I'll teach them. Make sure you subscribe to my channel so you will not miss out. Okay, so all these ones are all anions. Why all these ones are all cations? So cations and anions. Now, factors affecting the discharge of ions. This thing is very important because JAMB, we always ask it. If you check your JAMB pack, you always see questions on these things. Factors affecting the discharge of ions. Which ion will be discharged in preference to another ion? If you understand this thing, no more mistakes. Let's go. Factors affecting the discharge of ions. So there are some factors that affect the discharge of ions. The first factor is concentration of the ion. Concentration of ion. The second one that affects the discharge of ions is the nature of the electrode. Okay, nature of the electrode. So you have nature of the electrode. And the next one that also affects the discharge of ions is the case of discharge. Let me just see the ease of discharge. How easy it is for that ion to be discharged. This thing is very simple. Let me explain to you. The first one is concentration of ions. Concentration of ions has to do with that ion. How many are they? Like how much are they? If the concentration of ion is high, that means ions are much in number. If one ion is, maybe you have ions A and B, and A, you have, sorry, an example, you have 500 ions of A and 10 ions of B. You can see that A is much, so A will be discharged. So you understand? So concentration has to do with how that ion, how many are they? Like how much, how many are they? If one concentration is higher, the one that is higher will be discharged. The second one is the nature of the electrode. But before I explain the nature of electrode, let me do the ease of discharge. For the ease of discharge, you need to use what is called the electrochemical series. So this electrochemical series will help you to know which ion can be discharged in preference to another ion. Now, let me explain the electrochemical series for you. So it's very, very simple. Look at what you're going to do. For electrochemical series, all you have to do is just something like this. Electrochemical series starts with potassium. So it's called electrochemical series. The first one I'm going to start with is K plus. K plus means potassium ion. After potassium ion, you have maybe, you can say Na plus, you have Ca2 plus, Mg2 plus, and so on like that. Let me just put dot here, Cu2 plus, and so on. This thing means that if you have all these ions, okay, let me do an example. You have K plus and Cu2 plus moving, no, should be they are plus, Abi. Two of them are plus now, plus. Since they are plus, all of them will go to the cathode, which is negative, because plus and minus will attract. So if I have K plus, this is the cathode here, this is the cathode here, and K plus is coming to the cathode. Cu2 plus is also coming to the cathode. Which one will be discharged? Which one will be discharged? Now, to know which one will be discharged, it is the one that is lower in this arrangement, in this series, the one that is under that will be discharged. So if K plus is going there to the cathode, this is the cathode here, the negative electrode. and Cu2 plus also going there. It is the one that is under this series. That means Cu2 plus will be discharged, not K plus. This question normally comes out in exam many times under electrolysis. They'll give you two anions and they'll ask you that which one will be discharged. It is the one that is lower in this electrochemical series. So you need to memorize this electrochemical series. So it starts with K plus, Na, you have Ca, Mg, that's magnesium, followed by aluminium. Then you have iron, lead, and so on like that. So I'll just give you Cu. The last three are copper, silver, and you have gold. Gold, that is Au. So these three here, they are always the last. So the one that is lower in this series will be the one that will be discharged. Keep it in your mind, though, don't forget it. Then let me just explain the one for the negative anions. So for the anions. So for anions, which one will be discharged? For anions, the arrangement is nitrate first, nitrate NO3 minus. This is nitrate anion. Then you have SO4 2 minus. This is the sulfate anion. Then you have Cl minus. That's the chloride anion. Then you have Br minus, which is the bromide anion. Then you have another one, which is I minus, which is the iodide anion. Then you have OH minus, which is the hydroxide anion. Now, if all these ones are, these guys are they are negative, Abi, negative, 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 negative. Since they are negative, they will move to the anode now. Anode is positive, plus and minus must attract. So this is the anode here. The anode is positive. Now, SO4 2 minus is going there. Br, or let me use I minus. I minus is also going there. Which one will be discharged? It's the same technique for the one I did now earlier. It is the one that is below in this arrangement. You have to memorize this arrangement. Nitrate, sulfate, chloride, bromide. The one that is below, that is under, that's the one that will be discharged. You understand? So in this case, it means that iodine will be discharged instead of SO4 2 minus. Assuming it was nitrate that is going there, nitrate is coming here, and you have bromine coming here too. The one that will be discharged is the one that is under. Br minus will be discharged. That means bromine will be given off. This one means iodine will be given off. If it's OH minus that is there, let's assume Cl minus is going there, and OH minus is also going there. The one that is below is OH minus. OH minus is the hydroxide anion. And anytime hydroxide anion is discharged, a gas will be given off. They always ask it in JAMB. Like, which gas is given off when the hydroxide anion is discharged in electrolysis? The answer is oxygen gas, O2. Oxygen gas is always given off anytime OH minus is being discharged. The gas that will be given off is oxygen gas. So these are the factors affecting the anion that will be discharged. The next one is nature of electrode. Which electrode are you using? This is an electrolysis setup. This is your setup. This is your, let me just draw it here. This is your setup for your electrolysis. This is your setup. So which electrode are you using? Depending on which electrolysis are you doing. So let's assume I'm using carbon. Carbon electrode is called graphite. You know, graphite is a form of carbon. It's an allotrope of carbon. So if I'm using graphite and this electrolyte here is going to discharge oxygen, you have to be very careful because this carbon will react with the oxygen to form CO2, which is not advisable. The output of the CO2 will drop. So the nature of electrode you are going to use also determines. Then if you are using platinum electrode, platinum, that is PT, make sure you're not using chlorine. Make sure you're not doing anything that will give off chlorine because the chlorine will react with the platinum to give platinum chloride. So you need to be very careful. For an experiment or electrolysis that we give off oxygen, you can use platinum. It will not affect it. And for anyone that will give you chlorine, you can use graphite. It will not affect it. But don't use platinum when you are doing electrolysis that will give off chlorine because it's going to affect it. It's going to form platinum chloride, which will definitely affect it. And don't if the experiment will give off oxygen, don't use carbon because it's going to form CO2, which will affect the total output of the oxygen. So you don't need those two types. So let's keep that in mind. Now let's take an example now, proper electrolysis now. And we're going to apply all these things. And I'm going to show you how to write the equations. It's very simple. Now let's take the first one. We're going to look at the electrolysis of, let's say, sodium hydroxide. Let's start with electrolysis of dilute NaCl. Let me draw the diagram for you so you understand it better. So looking at the electrolysis of dilute NaCl now. So electrolysis of dilute NaCl. So this is dilute NaCl. So electrolysis. This question, JAMB normally asks this stuff, but I'll give you a trick. If something is dilute, it means there's water there. Just keep it in mind. Chicken, no waste your time at all. No stress yourself. Once something is dilute, water there. Water there for inside. So that means you are carrying salt, your normal salt, your table salt, the salt that is in your room or your kitchen. You now add water to it. That means you have formed dilute NaCl. So that dilute NaCl now, you now write NaCl. No, there's water involved. So you have to write H2O2. These are the two species that are involved in this electrolysis of dilute NaCl. Then you put dash here. That's the first one. Put another dash here. Second one. Now, these two guys will not dissociate. It means they will break down. Now, how will they break down? Look at the anions here. Which anion do you have here? This is Na plus Cl minus. So this one will break down to sodium Na plus. Then write plus here. Don't make mistake. Then Cl minus. That's how it will dissociate in solution. That's how it will break down in the electrolyte, in the solution there. It will break down like this. But since there's water there, water will also break down too. Don't forget, water will break down now. So that will be H plus OH minus. This one is hydroxide anion. This one is hydrogen anion. So that means since these two are negative, you now have the anode and the cathode. Which ones will go to the cathode? Which one go to the anode? These four guys, they are swimming inside the solution. They are swimming. They are dancing. They are dancing inside the solution, four of them. So immediately current starts flowing, they will now move to a particular part. Now, where will they move to? These two guys are negative, Nabi. These two guys are negative. Chloride and so that means since they're negative, they go to the positive part. Anode is plus, cathode is minus. So these two guys, Cl minus and OH minus, will come to anode. They will go to anode. Cl minus, OH minus. Nabi? Then cathode is the negative part. These two guys, since they are plus plus, they will come to the cathode. So you have Na plus and H plus. Now, which one will be discharged? Since this thing has happened like this, which of them will be given off? Which of them will be discharged? You now use one list not long ago. That list I gave you, you're not going to check it from your chemical series. You're going to check it. At your let me do the cathode first. At the cathode now, you have Na plus and H plus. From your chemical series I gave you not long ago, H plus is under Na. Hydrogen is under Na top. The one that is under, that's the one that will be discharged. So that means at the cathode, hydrogen gas will be given off. Hydrogen gas, H plus, will be given off. And they might ask you, write the equation. Don't be afraid, though. It's easy. Look how to write the equation. Don't forget, I told you that at the cathode, what happens at the cathode? Reduction. Reduction. What is reduction? Reduction is gain of electrons. So just write H plus. Okay, give it one electron. Then you're going to have H. Gas now. No, hydrogen is double. It's diatomic. You put G here. Then just put another 2 in front of this place. This is the cathodic equation. It is a reduction. Reduction means it will gain electron. You can see where it is gaining the electron on the left-hand side. It's gaining electron on this side. If you are gaining electron here, if you are gaining electron on this side, that means you are doing reduction. If you are gaining here, that means you are doing oxidation. Okay, so this is what will happen. Hydrogen gas will be given off. You can just put an arrow here. Put one small arrow here that shows that the hydrogen gas is given off. Then for anode now, these two guys are going to the anode. Anode is plus now, Abi. Which one will be discharged? Check your chemical series again for the negative ions I gave you. You know, the one I gave you, NO3 was starting it. I hope you got the note. So NO3 was starting it. The one that is under will be discharged. So that means OH minus will be discharged. And anytime OH minus is discharged, anytime, that means the gas is O2. Anytime OH minus discharges, it will give off a gas. That gas is oxygen. Take note, they might ask you in exam. Yes, they repeat pattern in mathematics and physics in past questions. Yes. They normally repeat their questions. JAMB normally repeats questions. So just master your past question very well. You can also join my class. I run an online class for JAMB 2026. I've already started already. I've already started the online class. So we add lectures today, but see tomorrow that we have chemistry. So you can join the online class. It's a very affordable class, just from now till next year. I'm teaching the subject from now till next year, and just they're going to join and pay, or just only once. It's just 12,000 naira to join the class, just 12K. So once you join 12K, you're not paying any money again till next year, April, and I'm going to give you all the support you need. My school BT software you need and everything. The highest score in my class this year was 312. So I want to break that record this year. The highest score, one of my students scored 312. You had 280, you had 290, but the highest among them was 312. But I want to produce 330 plus. I want to beat some records. So that's why I'm inviting you guys to join in. So let's continue, Sha. So as we proceed now, these two guys are going to the terminal, Nabi, the anode. So OH minus will be discharged. And anytime OH minus is discharged, oxygen gas will be given off. So how will you write that equation? Anytime oxygen gas is given off. So just write, you're going to write OH minus. Listen carefully, OH minus. You could put 4 in front of it. Okay, that's 4H minus. Then put line here. That will be 2H2O plus, it will give you oxygen, O2 plus 4E minus. This 4E minus here, it means you are using 4 moles of electron. Okay, this equation is very, very common. Anytime OH minus is discharged, this is the equation. The gas there is O2. You can see oxygen gas is giving off. You have 4OH minus giving 2H2O plus O2 plus 4E minus. Very, very important. Please don't miss this. So that means in the electrolysis of dilute HCl, 2 things will be given off: oxygen and hydrogen. So you can see that's what will be given off. That's what will be discharged, rather, if you want to put it like that. So I hope you understand. Let's look at another one: electrolysis of molten NaCl. So this one is molten NaCl. If something is molten, that means I've melted it. Molten NaCl. So if you try this one, so if it's molten, that means there's no water. There's no water. No water. Very important. So this is the only stuff we're going to have. We're going to have Na plus Cl minus. In this place will be NaCl only. There's no water there. There's no water. So you're going to get this. Then from here, this is what is going on. You can now know which one will be discharged. Since they're not disturbing it, nothing is disturbing anything. 2 of them are alone. That means you're going to get this one will go to the cathode. This one will go to anode. So at the end of the day, you're going to get Na plus, since that is cathode, Na plus is going to receive 1 electron and it's going to form Na solid. This is reduction. For chlorine, it's going to be Cl minus. This is oxidation, so it will form Cl2 plus E minus. This will now be a gas. And you just put 2 here. So this thing is very important too. This one here is oxidation. This one is reduction. Why? Because at the cathode, you have what is called reduction, and at the anode, you have what is called oxidation. So I hope you understand what I've taught you. Okay, so just to digress a little bit, this topic is very, very wide, and I would like you guys to gain more understanding of it. You can join my online class if you need more understanding for this particular topic. So I'll move on to the next subject. I hope you understand this particular chemistry. So note where we stop. We'll continue in the next section. So I'll move to the other subjects for today. So someone said I should teach scalars and vectors, motion waves, and all those things like that. So It's noted. I'm going to teach all those topics for you guys. I'm going to teach you guys, and you have to be practicing. Now, I'm going to give you some tips. Some tips. There's a book called JAMB Remix. You guys will know it now. JAMB Remix. It's a very good book. It will help you to score high. To score high in JAMB. So to score high in JAMB, you need that book, JAMB Remix. You can buy the physical copy. The book is available in physics. They have the physics, they have the chemistry, they have the biology, they have the maths. But I don't know of other departments, or maybe they have econs or so on like that. I don't know. But these are the ones that they have. They also have English too. And that book is very, very good because the guy there, he did a great job. He arranged all the topics, all the questions according to the topics. So that JAMB Remix, you need to finish it. There are so many questions there. Only even in organic chemistry alone, there are about 400 in chemistry alone, in that book, there are about 400 organic chemistry questions there. Organic chemistry, 400. As in the history of JAMB, the guy put everything together. So that means if you can finish that 400 questions, you note them very well. There's no how that JAMB will not repeat question from there. It's not possible. They must repeat question. And JAMB normally repeat question every time. Imagine exam that they have been doing since 1978. Since 1978. Don't you think they would have repeated question? They don't have questions again. They don't have questions. This topic I just taught you now, this acid base and salt. Sorry, this electrolysis. There's no how they ask question that will not be in what I've said. You can only twist it. So that means you must finish that book. Please finish it. If you want to score high in JAMB next year, you must finish that book. One, that's the first thing. Your syllabus. Also finish your syllabus. At least this before December this year. Before December of this year, at least finish 80%. Because you have to be reading now. It's not like when it is January that you now start reading. Then the rush will be too much. The rushing will be too much. You have to start reading now before December. Then the next thing you need to do is that you need to be reading for like a long time. You need to stretch your brain a little. Ignore distractions. Ignore distractions and study very well. You see that there's no that you will not score very high. And to score high, please, your past question is very important. Past question, PQ. Don't underrate it. Do your past question very, very well. Do it very well, and you're going to score high. Then lastly, my number here. This is my number here. If you need my help, 070388. This is my number here. I also run JAMB classes. You run JAMB classes, and our class is just 12,000 naira from now till for 8 months. So this is a special offer. You cannot see this offer anywhere. On the JAMB class, we have started already. We started lectures already. So in chemistry, now we're doing chemical bonding. In biology, we're doing nutrition. In mathematics, we are doing salts. Okay, and in physics, we are doing momentum. So you can join us and partake in this class. So my number is 070-388-45741. Okay, so thank you for supporting EduMath Up. I really appreciate you guys. Thank you and remain blessed. Thank you guys. Bye.